Seventh root of p to the fourth power equals to t to the power of 5 over 6. In the given equation, p is greater than 1, t is greater than 1. If t equals to p to the power of 2n negative 1, where n is a constant, what is the value of n? Okay, now what we can do is we can plug in this p to the power of 2n negative 1 for t over here in the given equation, because t equals to p to the power of 2n negative 1. Okay, now let me plug in, then we get 7th root of p to the power of 4 equals to, for this t, we can plug in this one, then we get p to the power of 2n negative 1. And we can take this exponent as it is, that is 5 over 6. Here we have radical on the left side of the equation. Whenever we have radical, it can be written as exponent. Okay, when I write a radical as an exponent, it has to be a fraction. The numerator has to be 1. The denominator of the exponent has to be the index of the radical. Here the index of the radical is 7. Okay, p to the fourth power. Now I am going to write this radical as an exponent. Then the exponent will be a fraction with numerator 1. And the denominator is the index of the radical, that is 7. Okay, here a power is raised to another power. Whenever a power is raised to another power, we can multiply the two exponents. Then we get 5 over 6 times 2n and negative 1. Okay, now we can do the same thing on the left side. That is, a power is raised to another power. We can multiply the two exponents. Then we get p to the power of, when I multiply 4 and 1/7, I am getting 4 over 7 equals to p to the power of 5 over 6 multiplied by 2n negative 1. Here two powers are equal with the same base, that is p. Whenever two powers are equal with the same base, what we can do is we can equate the exponents. Okay, when I equate the exponents, I am getting 4 over 7 equals to 5 over 6 times 2n and negative 1. Let me multiply both sides of the equation by 6 over 5. Let me do it over here. So I want to get rid of this fraction. That's why I multiply both sides of the equation by 6 over 5. So this 6 will cancel out. This 5 will cancel out. Okay, here 6 times 4 is 24 and 5 times 7 is 35 equals to 2n negative 1. Okay, now to solve for n, we have to isolate n. Let me add 1 to both sides of the equation. When I do so, this negative 1 positive 1 will cancel out. I am getting 24 over 35 positive 1 equals to 2n. Okay, here I am adding a fraction and an integer. Whenever I want to do addition or subtraction between a fraction and an integer, I have to multiply the integer by the denominator of the fraction. Once I am done with the multiplication, I can take this 35 as a common denominator. Okay, let me do it. 24 positive. 1 times 35 is 35. Now we can take 35 as a common denominator equals to 2n. Okay, let me continue over here. When I add 24 and 35, I am getting 59 over 35. Equals to 2n. Okay, now to solve for n, we have to get rid of this 2. For that, we have to multiply both sides by 1 over 2. When I do so, this 2 will cancel out. 1 times 59 is 59. 2 times 35 is 70. On the right side, we have n. Here I got the value of n, that is 59 over 70.